Good morning, all of you. Myself, Dr. P.C. Dikshit. Today topic is matrices, in which first we discuss the eigenvalues and eigenvector. Second, we Cayley-Hamilton theorem, rank of a matrix, solution of a simultaneous equations. So now let me start the first eigenvalues and eigenvector. So now let me start eigenvalues. Let A be any square matrix and lambda be a scalar, then determinant of A minus lambda I is called a characteristics equations or eigen equations. Say that means lambda equal to lambda 1, lambda 2, lambda 3 or called the eigenvalues. For example, let us consider a matrix 3 cross 3 order matrix, that is 1, 2, 3, 0, 2, 4, 0, 0, 3. So find its eigenvalues and eigenvector. So now let us consider identity matrix of 3 order 1, 0, 0, 0, 1, 0, 0, 0, 1 multiplying by lambda. So lambda I equal to lambda 0, 0, 0 lambda 1 and 0, 0 lambda. Now applying the characteristic equations, condition of characteristic equations, A minus lambda I determinant equal to 0. So A minus lambda I. So subtracting A minus lambda I, so it becomes a 1 minus lambda 2, 3, 0, 2 minus lambda 4, 0, 0, 3 minus lambda. Now applying the determinant properties, expand by the first row. So here we get the 1 minus lambda, 2 minus lambda, 3 minus lambda in multiple equal to 0. So 1 minus lambda equal to 0, so lambda equal to 1. 2 minus lambda equal to 0, so lambda equal to 2. 3 minus lambda equal to 0, so lambda equal to 3. So therefore, eigenvalues are 1, 2 and 3. If these eigenvalues, also we can write this in set form, that is called a spectrum. Now again we to find the eigenvalue vectors and the eigenvectors for which applying the condition matrices A minus lambda I into x equal to 0, where x equal to x1, x2, x3 and 0 is null matrix 0, 0, 0. So we can write this A minus lambda I into x, that means 1 minus lambda 2, 3, 0, 2 minus lambda 4, 0, 0, 3 minus lambda x1, x2, x3 equal to 0, 0, 0. So now first we put lambda equal to 1. Here we find the all eigenvector corresponding to the all eigenvalues. So first we put lambda equal to 1. So lambda equal to 1, so that it becomes a 0, 2, 3, 0, 1, 4, 0, 0, 3, x1, x2, x3 equal to null matrix 0, 0, 0. Now after multiplication it becomes a 0 into x1 plus 2x2 plus 3x3 equal to 0. That means 2x2 plus 3x3 equal to 0. That is equation number 1. Again be 0 into x1, 1 into x2 plus 4 into x3 equal to 0. It becomes x2 plus 4x3 equal to 0. Now here we are multiplying by R3 to C1. So 0x1, 0x2 plus 3x3 equal to 0. Here we get the value of x3, that means x3 equal to 0. Putting these values x3 in 1, so we get x1 equal to k, x2 equal to 0. Now if two values becomes a 0, so the third value will be take k1, x1 equal to k, not equal to 0, 1, 2, 3 and up to so on, because all eigenvectors are in non-zero forms. So the first eigenvector is k0, 0, that means k common 1, 0, 0. Now again we put lambda equal to 2. So that means minus 1, 2, 3, 0, 0, 4, 0, 0, 1. It becomes x1, x2, x3 equal to 0. After multiplication, here we get the values of x3 equal to 0, but minus x1 plus 2x2 equal to 0. So after simplification, it becomes in ratio form. That means x1 upon 2 equal to x2 upon 1 equal to k. Say, that means say, not equal to 0. So after simplification, here we get the x1 equal to 2k, x2 equal to k. So second eigenvector is 2k, k 0, k common, so it becomes a 2 1 0 0. Now again we find the eigenvector corresponding to lambda equal to 3. So put lambda equal to 3 in previous equations 1. So here we get the another matrix minus 2 2 3 0 minus 1 4 0 0 0 x1 x2 x3 equal to 0 0 0. After simplification and multiplications, it becomes a minus 2x1 plus 2x2 plus 3x3 equal to 0. And also 0 into x1 minus x2 plus 4x3 equal to 0. So equation number 2 convert in ratio form. That means x2 upon 4 equal to x3 upon 1 equal to k. Say, so therefore x2 equal to 4k, x3 equal to k. Putting these values in equations number 1, so here we get the value of x1 equal to 11 by 2k. So that becomes the third eigenvector. We can write this k by 2 in k, 4k and k. K by 2 is common, so that is 11, 8 and 2. So that is the required solution. So here we find the all eigenvector corresponding to each eigenvalues. What where we noted that always eigenvector are in non-zero form. Number 2, any variable x1, x2, x3 does not present in any equations, so we can consider always k. K is not equal to 0. Rule number 3, eigenvector are in ratio form. Suppose equation becomes in two variable, so directly convert in ratio form, find the eigenvalues, and fourth one is more eigenvector corresponding to the one eigenvalues. More eigenvector corresponding to the one eigenvalues. If two values of lambda are equal, so we get always a single equation in x1, x2, x3. And property number last 6 formula. Here we get these three equations in three variables x1, x2, x3. So applying this formula, find the value of x1, x2, x3. Now applying the formula x1 upon p minus o, that means principal diagonal minus off diagonal, equal to x2 upon principal diagonal minus off diagonal, equal to x3 upon principal diagonal minus off diagonal. So these are the all six properties. Remember always for eigenvalues and eigenvector. Now again be applying it. Consider another examples a equal to 1 minus 2 minus 5 or 4. The order of these matrix is 2 cross 2. So now characteristics equation a minus lambda equal to 0. So a minus lambda, that means we can write this 1 minus lambda minus 2 minus 5 4 minus lambda equal to 0. After simplification, 1 minus lambda 4 minus lambda minus 5 minus 2 into equal to 0. So here we get the quadratic equation in lambda. Lambda square minus 5 lambda plus 6 equal to 0. After after factorization, here we get a lambda 1 into lambda minus 6 equal to 0. So the value of lambda is minus 1 and lambda equal to 6. Now to find the this lambda equal to minus 1 and lambda equal to 6 is called the eigenvalues. So eigenvalues are minus 1 or 6. Now to here find the eigenvector corresponding to the each eigenvalues. So first we put lambda equal to 1. So we get the equations 2 minus 2 minus 5 5 x1 x2 equal to null matrix. So now after multiplication it becomes a single equation minus x1 5x1 plus 5x2 equal to 0. That means x1 equal to x2. That means k. So therefore, first eigenvector is 1, 1. After taking common, so it becomes a 1 and 1. Now again put lambda equal to 6, so minus 5 minus 2 minus 5 minus 2, again we becomes a single equation in two variables, minus 5x1 minus 2x2 equal to 0. So we can write this x1 upon 2 equal to x2 upon minus 5. Say it is k. After simplification, x1 equal to 2k, x2 equal to minus 5k. So we can write that the second eigenvectors 2k minus 5k. K is common, so that is the second eigenvector is 2 minus 5. So these are another more examples. Another more examples. 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3. Find its eigenvalues and eigenvectors. So first we find its characteristics equations. So its characteristics equations is lambda minus I equal to 0. Lambda I, that means we can write this 8 minus lambda minus 6, 2 minus 6, 7 minus lambda minus 4, 2 minus 4, 3 minus lambda equal to 0. After evaluation of determinant, here we get the equation in lambda, that is a lambda minus lambda cube plus 8 lambda square minus 45 lambda equal to 0. Lambda is common, so we get the all factor term equation. It becomes in all factor terms minus lambda, lambda minus 3, lambda minus 15 equal to 0. After simplification, here we get the value of lambda equal to 0 and lambda equal to 3 and lambda equal to 15. These values are called the eigenvalues. So here we find the eigenvector corresponding to these eigenvalues. Now applying the conditions for eigenvectors, matrix A minus lambda into x equal to 0, 0 means null matrix. Now here we write the value of A minus lambda I, that is 8 minus lambda minus 6, 2 minus 6, 7 minus lambda minus 4, 2 minus 4, 3 minus lambda, and value of x, capital X, that is x1, x2, x3, and that is equal to O, that means in null matrix 0, 0, 0. So now I find the, that is equations number 1. I have find the eigenvector corresponding to each eigenvalues of lambda equal to 0, lambda equal to 3, and lambda equal to 1. So first we put lambda equal to 0 in equation 1. So 1 becomes a form 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3. In multiplying by matrix x1, x2, x3 equal to 0, 0, 0. After multiplication of a matrices, here becomes a 3 equation in 3 variables. So taking last 2 equations, applying the formula, it is given in previous, that is x1 upon the principal diagonal minus of diagonal equal to minus x2 upon principal diagonal minus of diagonal, or x3 upon principal diagonal minus of diagonal. So applying this formula, so here we get a x1 upon 5, x2 upon 10, and x3 upon 10. It is a ratio, so we can write this x1 upon 1, x2 upon 2, x3 upon 2. Say it is k, so therefore x1 equal to k, x2 equal to 2k, x3 equal to 2k. So that is the first eigenvectors k, 2k, k. Taking k is common, so that is the first eigenvector is k into 1, 2, and 3. So that is a eigenvector corresponding to the lambda equal to 0. Now again we find the eigenvector corresponding to the lambda equal to 3. So put lambda equal to 3 in equations 1. After putting these lambda values equal to 3 in equation 1, we get a 5 minus 6, 2, minus 6, 4 minus 4, 2 minus 4, 0, x1, x2, x3, and equal to null matrix. 5x1 minus 6x2 plus 2x3 equal to 0, minus 6x1 plus 4x2 minus 4x3 equal to 0, and 2x1 minus 4x2 equal to 0. After from equations number 3, that is equation in two variable, so it is immediately converted in ratio form. we can write this x1 upon 4, x2 upon 2, say it is k. So x1 equal to 4k, x2 equal to 2k. So putting these values in any equations 2 and 1 and 3. So put in 1, so 2k minus 12k plus 2k 3 equal to 0. So that means 2x3 equal to minus 8k, x3 equal to minus 4k. Therefore, second eigenvector is 4k, 2k minus 4k. K is common, so that is a 4, 2 minus 4. Now again we find the eigenvector corresponding to lambda equal to 15. Put in 1. So we get another equation in matrix and multiplying by x1, x2, x3. We got the three equations in three variables. So taking any two equations from 1 and 2, applying the previous formula in ratio form, that is x1 upon 24 plus 16, x2 upon 28 plus 12, and x3 equal to 56 minus 36. X1 upon 40 minus x2 upon 40 equal to x3 upon 30. It is in ratio form, so we can write this also x1 upon 2, x2 upon 2, and x3 equal upon 1 equal to k. Same. So E3 equal to 2k minus 2k k. K is common, so 2 minus 2 and 1. So that is a third eigenvector corresponding to the lambda equal to 15. So applying the or more problems to find the eigenvalues and eigenvectors, applying the conditions and properties of eigenvalues and eigenvectors.